back to my channel. If you are here on this channel for the first time, please click on the subscribe button and click on the notification bell to get updates from our channel. Let's consider mathematical representation of progressive wave motion. A progressive wave is spread out from a vibrating body and moves through a medium and transfer energy as it moves or as it travels. These waves transfers energy as they travel. So we have a equation for this. The equation is y equals to a sine 2 theta x over pi, and our y is the vertical displacement of vibrating body particle. Our lambda is the wavelength, our a is the amplitude, and the x is the horizontal coordinate of the vibrating particle from the origin. Still look at this diagram. You have the origin from the y coordinate, where the y and the x coordinate meet. That's the origin, and the wave moves in the positive direction of the x coordinate. So, and the wave can also move in the negative side. So this 2 pi x over lambda is also known as is the phase difference of the wave particle at the distance x from the origin. So now let's look at the displacement can be represented by the following equation after a time t. That's when this particle moves from the origin to a distance x in t time, that's in time t. So we'll have these equations being changed. So we'll have it can move in the positive direction and in the negative direction. So now you can see, now the first one we have y equals to a sine 2 theta over lambda in bracket of x minus vt. That's when it moves, when the wave moves in the positive direction. And look at it in your right hand side. You have your y equals to a sine 2 pi over lambda bracket vt minus x. That's when it moves in the negative direction. When the wave moves in the negative direction, you can see that these equations, they have the same parameters but in a different way. So another equation, now look at the second one. That's y equals to a sine 2 pi in bracket of x over lambda minus ft. That's when it moves in the positive direction. You can see we are just substituting some values from one equation to another. So and look at the right hand side too. You have the negative direction there. Another one is a sine 2 pi in bracket of x over lambda minus t, that's small letter t over capital letter T. The capital letter T is the period. You see, you know that your F equals to the 1 over T. So that's why we now substitute our F in the equation 2 with 1 over T. That's how we now have T, small letter T over capital letter T. And on the right side too, you can see the negative directions equation. And the last equation here will have y equals to a sine in bracket of 2 pi x over lambda minus wt. Now, you know, now we substitute our t or our frequency. Now we substitute with w here. So that's it. And see the negative direction on your left, on your right hand side. Now let's do some questions. A progressive wave equation is represented by y equals to a sine bracket 150 pi t minus pi x over 4, close the bracket. If the phase difference of the progressive wave is 45 degrees, the value of x in the equation is, so we have to find the value of x in that equation. So comparing this equation that we were given, compare it with the standard one that we have, one of the equations that I've given you, compare with y equals to a sine you see that we have our t here, so that shows that this wave now is moving in the negative direction. So we'll have wt minus 2 pi x lambda. Why do we choose this equation? When you look at the equation you were given, you will know which of the equations that are listed for you, you know which one you should choose. So from the parameters we have, these two matches. So now we are asked to calculate the value of x. So now we're gonna use this to equate this. So we'll have pi x over 4 equals to, I told you that this value is the phase angle, and we're given our phase angle as 45 degrees, so we'll add 45. Now what you now do now is pi x equals to this 4 multiplied by 45, and then your x will now be 45, which is 180 divided by pi. And from your trigonometry, you know that your pi is 180 because you have 2 pi equals to 360. You get it right? Now your pi equals to 360 divided by 2, then pi equals to 180. You get it right? So here our x equals to 1 centimeter. You get it right? Good. Now let's do another example. The equation y equals to 5 sine bracket open 3x minus 4t, where y is in millimeter and x in meter and t is in seconds, represents a wave motion. Determine a, the amplitude. We are asked to determine the amplitude. That's the first thing to determine. The second one, frequency, and the third, the period, and the fourth, we have to determine the speed of the wave. So now comparing this equation that we're given, you have to compare it with, now if you look at your equations that I gave you, you'll see this will look some alike. We can use this also. This wave now is moving in a positive direction, right? You get it? Now comparing this, now we have to look for the amplitude. Now comparing this, now I told you a is amplitude. That means our amplitude, that's the first question, our amplitude is 5. Now we have to calculate the frequency. So now let's use from your knowledge of simple harmonic motion, your W is 2 pi f. Now you have your T compared to this 4t. Now divide both sides by t, you have this cancelled out, then your f equals to, now when you divide both sides by 2 pi, you have 4 divided by 2 pi. Now you have your f to be, when you punch this on your calculator, you have about 6.284. Then 4 divided by 6.284, you have 0.64. Then you remember your unit, hertz. Now let's calculate our period. Our period is inverse of the frequency. Now we have 1 over 0.64. Our frequency is 0.64, and then that inverse will now give us 1. If you punch that on your calculator, you have 1.56 then seconds. Now our period is 1.56 seconds. Now we are asked to calculate our speed of light, that is the speed of the wave. So we know that our speed is this. From your knowledge of wave, speed is this. Now we got to calculate, we have our frequency, so we need our wavelength. So getting our wavelength, now we'll have let's now use this to equate this. We'll have 3x equals to 2 pi x over lambda. Now this cancel this. Now lambda now will be what? 2 pi over 3. And then 2 pi over 3 will give you what? Okay, let's just leave it like that. Now, I don't want us to have I want to deal with decimals. That's why I say we should leave our wavelength this way. Now we have our wavelength to be like this. So V equals to F lambda. Now we have our our F to be 0.64 multiplied by 2 pi divided by 3. Now we'll print this on your calculator. Now you're gonna have 1.34 meter per second. Here is the speed of the particle. Now you get it. Now do these exercises and see whether you'll be able to arrive at the answer. Thanks for watching, and please click on the subscribe button and share this video to friends. Thank you. Solution.